polynomial and rational inequalities. We want to be able to solve these inequalities. The schematic setup that I present to you is kind of similar to the scheme that I set up for the rational functions, and even also just for graphing, period. That is, we want to be able to find those critical x values, partition the number line, test the signs of each interval, and then from there, graph or here solve. So we're going to solve these. It could be a polynomial inequality, and when they say that, they're just talking about something like x squared minus 3x plus 8 greater than or equal to 0. Or when they say rational, could be x minus 2 all over x plus 3 is less than 0. The same method that we'll use to solve them all. No modeling, that is no applications, that is no word problems. Just want to make sure that you all get the basics here, and then we'll move on. This is all verbiage from the book. I do have a page where I list my steps, and I put that in. We're going to follow that. My information, I think, is pretty basic and straightforward. Polynomial inequality is any inequality that can be put into one of the forms: function less than 0, function greater than 0, function less than or equal to 0, function greater than or equal to 0. So these are the steps that he gives, and these are my steps. So let's look at my steps to solving polynomial and rational inequalities. We're going to get all the terms on one side of the inequality, preferably on the left side. Set the expression equal to 0. That is that information on the left side. Set that equal to 0. Solve for x. We call these values the boundary points. Years ago, I just called those critical values, and I call those critical values just to get you set up for calculus, because in calculus, we have something over there called critical values. Not necessarily these, so it's probably good to call them boundary points. We just say that these are some dang on crazy x values. How about that? So you can label it like that. We'll do the Chris Rocks. It's some crazy dang on x values. Number 3, partition, that is cut up, slice up the number line based on those boundary points that you got for step number 2. Test each interval to determine the sign of each subinterval. We've been doing that in the previous sections, for graphing. That's the same thing we're doing here. Determine the overall sign, if it's a product or a quotient, and then from there, you should be able to write the solution set or solution sets. So let's take this problem here. Everything is on the left side. So you set this left side equal to 0 and solve for x. That implies x equals to 8, x equals to -2. Now we're going to partition the number line based on those x values. So we go from least to greatest, so -2. And this is going from negative infinity to -2, and then we get to that 8, and then plus infinity. So now what we're going to do is we're going to test each interval, take a number, and just plug it back over to that left side and see what sign value we get, right? So let's see, a -3. Maybe I put in red the test values. I know. So test -3. What's between -2 and 8? That's easy, 0, right? I pick a number close to 8, so pick 9. So you plug in -3 for x, see what sign. All I'm interested in is the sign. You can get the number, but it's the sign of that number that you want, right? So plug in -3, I get -3 minus 8, -3 plus 2. So this gives me, really it's going to be negative times negative, so it's positive. So this is -11 times -1. Again, all I want is the sign. You test 0, 0 minus 8 times 0 plus 2, negative times a positive, negative. I just want the sign again. Test 9, so 9 minus 8, and then 9 plus 2, positive. Right? So here we test x equal to -3. Here we test x equal to 0. Then here we test x equal to 9. We get the sign, right? So this here says greater than, that means positive. So I want the intervals that are positive. The intervals that are positive is this interval and that interval. What interval is that? That's going to be from -infinity to -2. It says greater than, doesn't say equal, so it's just parentheses, union. And then we come over to the other positive interval that goes from 8 to positive infinity. You find that the graph, let's see, where is it? So on that left side, it's a -2. Is that -2? And then we need the 8. See here, 10, 9, 8. That's an 8. Yep. And so that's that, and that's that, right? So it doesn't include the endpoints. You put a bracket, but we do the parentheses. That means it's open. So we pick A. All right. So you kind of get the gist of it. You can kind of move along. So here we get x equal to 7, x equal to -5. So we partition this number line based on those values. Go from left to right now, -5 to 7. You know, it's positive infinity, negative infinity. So we're going to test some numbers on these intervals. Pick -6 to test. Sorry, I'm not using 0. I mean, not using red. And then we'll pick 8 over there. All right, so we pick that -6, plug that in for x. So we get -6 minus 7 times -6 plus 5. That's negative times the negative, we get positive. Put the positive up there. Test 0, 0 minus 7 times 0 plus 5, negative times positive is negative. Put that negative up there. What you waiting on? All right, so we test 8. So I get 8 minus 7. See, I'm plugging that back into the original for x, right? And then 8 plus 5. Just the sign, positive and positive, positive. Now, this is less than, right? That's negative. So where is it negative? Right here on that interval. That goes from -5 to 7. Right? And since it says less than or equal to, that means bracket. And we find that. That's it right there. -5 to 7, everything in between. Now here you have to factor to get those critical values, those boundary points. That term boundary point, that's pretty cool. That's high-tech math talk right there. Let's see if we can factor this. X minus, I don't know, times X something, minus or plus, I don't know. The factors are 15, 3, and 5. And are they both negative? Yes. You add 2 negatives, you get negative. Multiply 2 negatives, you get positive. So that's good. So that's greater than 0. The critical value is x equal 3, x equal to 5. We slice up the number line based on those values. Go from least to greatest. So 3, 5. Going from -infinity positive infinity. Pick some test values. 0's over there. 4 is in between. 6 is right there. So we test 0. Put 0 here, 0 there. Negative times negative is positive. I mean, if you kind of get it, you can kind of look at it and keep moving. Let's see. So you plug in the 0. You can even plug it here. 0 there, 0 there. You just get positive 15, positive. Right? Plug in the 4. Right? 4 minus 3, that's positive. 4 minus 5, negative. Positive times negative is negative. Test the 6. We get positive, positive. Positive times positive is positive. All right? So, I mean, you can plug those in there, and just do it one at a time. So x equal to 0. 0 minus 3 times 0 minus 5 gives us positive 15. But we just want the sign. Test x equal to 4. And for the next problem, I'm not going to write all this because I want you to see it. You get it. Keep moving. So this is 4 minus 3. And this is 4 minus 5. Right? So that's 1 times a negative 1. So that's negative 1. Just negative. That's the only thing I want is the sign. Right? That's how I got that. And then we test x equal to 6. So we get 6 minus 3. See, that's positive. And then 6 minus 5. That's positive, right? So that's 3 times 1. That's 3 anyway. It's positive. So here you want it to be greater than 0. So the intervals that is greater than, you look at the plus signs. So the answer, let's write it in the interval notation. So that goes from negative infinity, positive, negative infinity to 3. It's parentheses because it doesn't have a line under there, right? And then that's union with where else is positive, from 5 to positive infinity, right? So that graph, basically, when you do that number line partition, you got the graph right here. If this says less than, then that would be the answer. So that graph, straight line. That's the 3, and then 5 to positive infinity. All right, this one right here, everything's on the left side. Again, we get those critical values. You set this guy equal to 0, and we get from that x equal to 1, x equal to 2. We test those. Take the number line, divide it based on those values. So we have a 1, a 2 there, right? So then we're going to test for zeros over here. See, 3/2 is there, or 1.5, right? And then a 3. Again, all I want is the sign. Plug in the 0 there and there, you get negative divided by negative, you get positive. Take that 1.5, plug it up in the numerator. 1.5 minus 1 is 0.5, that's positive. 1.5 minus 2 is negative 0.5, so that is positive divided by negative, we get negative. Put the 3 in, we get positive and positive, we get positive. All right. So where is it positive? Well, I'm sorry, where is it negative? Because this says less than, right? So you want the negative interval. That's that one in between. So here, this goes from 1 to 2. So our answer, the interval will go from 1. It's going to include 1. It wants to include 2, but 2 is downstairs, and x cannot equal to 2, so it's parentheses there. And then so that graph would be, here this is the 1, to 2, 1 to 2. Okay. Last one. Notice that 2 is on the right side, so I need to get that on the left side. Get everything on the left side. Why? Because old Dave said so. Get all the terms on one side of the inequality, preferably on the left side. So again, when I ask you questions, I'm not asking you to just try to pull up something, from Star Trek or, from Leave It to Beaver. Why am I calling these old shows that folk don't know anything about? Because I don't watch TV now, so I don't know what's on. So, so we're going to subtract 2 on both sides. So it's x plus 4 all over x plus 9 minus 2. That's less than 0. So here we combine 2 fractions. We're going to write this as one term. So remember, this is 2 over 1. So the least common denominator is x plus 9. So this is x plus 4 over x plus 9, minus 2 times x plus 9 all over x plus 9. All right, because x plus 9 divided by x plus 9 is just 1 times 2. That's still 2. But the only way that I can combine these 2 fractions is they got to have the same denominator, right? So since my denominators are the same, I can combine. So I can write everything over the common denominator. So this is x plus 4 minus 2 times parentheses x plus 9. Simplify. X plus 4 minus 2x minus 18 all over x plus 9. And this is all less than 0. Sorry, less than. Can't forget that, less than 0, less than 0, less than 0. Simplify. X minus 2x is negative x, and then 4 minus 18 is negative 14 all over x plus 9, and that's less than 0. Now it looks like something that we've had before. So we set each term equal to 0, solve for x. So we have negative x minus 14 equal to 0. We get negative x is equal to 14, x is equal to negative 14. And then x plus 9 is equal to 0. We get x equal to negative 9. So I take the number line and I partition the number line based on these 2 values. Go from least to greatest because I'm going from negative infinity on the left side. The next number I come up to is negative 14 and then negative 9, right? Let's test some values in between. So let's see here. There's a negative 15 over there. It's a negative 10 here. And then 0 is over there. I always try to get that 0, man. I've been everywhere, man. I've been everywhere. All right, let's see. So, so here we go. We're going to test x equal to negative 15. So that's, we plug them into x, right there. So this is negative times negative 15 minus 14 all over negative 15 plus 9. Just simplify that. So this is 15 minus 14 all over negative 6. So this is 1 over negative 6, or just negative 1/6. All you want is the sign is negative. Put a negative there. Let's test negative 10. X equal to negative 10. So this implies that I have negative times negative 10 minus 14 all over negative 10 plus 9. That becomes positive 10. 10 minus 14 is negative 4. And then this is over negative 1. So we get positive 4. Anyway, it's positive. So all you want is the sign. All right, then we test 0. That's easy. I've been everywhere, man. So 0 minus 14 over 0 plus 9. Negative divided by positive is negative. Well, since all this stuff, this is the final, result. It's a quotient. Is less than. Less than means negative. Where is this negative? Is negative here, and it's negative there. So those two intervals are the solution, and thus the graph that follows. So we write our answer. It's like I'm going back up. Apologize for that. Maybe I see if I can just plug it in down here. So the answer would be from negative infinity to that negative 14, negative infinity to negative 14. Now, does it include the 14? Well, it's just less than. It's not equal to. So we don't have that. So we don't put bracket. So it's strictly parentheses. Union. Where else is it negative? From negative 9 to positive infinity. All right. So from negative 9 to positive infinity. Now, if it had this less than or equal to, if it had that, it would be a bracket on the negative 14, but it'll still be a parenthesis at negative 9 because that negative 9 is in the denominator, and the denominator can never equal to 0, right? So if this guy right here is less than, then you look for the negatives. If this was positive, greater than, that'll be positive, then you'll look there. That'll be your answer. Okay, put it back right. Does that make sense? All right, well, folks, that's it. I forgot the graph. So look here. So I'm going from negative 14 all the way back to the left here to that to negative infinity, and then we jump over to negative 9, and that goes that way to positive. That's going to plus infinity. So you look at the graph to see where that is.